Ladies and gentlemen, welcome to BuildUp, the European portal for energy efficiency in buildings. My name is Alessio Rimoldi. I'm Secretary General of BIBM, the Federation of the European Precast Concrete Industry, VEEP partner and your moderator for today's webinar. Before starting, next slide, you will see I would like to thank BuildUp for offering us the possibility to use this portal for presenting today's topic. BuildUp is a regularly updated collaborative platform and key source of information on energy efficiency in buildings. If not yet done, you can register and become a member of the BuildUp community, allowing you to submit content like news, events, publications, and so on. Next slide, you can see that after the webinar, I will invite you to navigate through the portal. In the Learn section, you will be able to find the podcasts to past webinars, including the recording and the whole presentation of today's event. Today, I'm honored to guide you through the discovery of 3 research projects promoting circular economy for buildings: VEEP, Ceramco, and ICEBERG. If you are here with us today, it is probably because you share our ambition to reshape the built environment with circularity in mind. When looking at the agenda, you can notice that the focus will be on VEEP, as this is the final dissemination event of such project. This part of the webinar will be a combination of presentations, interviews, and movies that will guide us through the work and achievements of such project. Ceramco and ICEBERG will be presenting in a clustering session that will be followed by a dedicated time for questions and answers, just before wrapping up everything in a concluding statement by the VEEP coordinator. As mentioned above, this webinar will be recorded, and by joining, you are consenting to this registration. The recording of the webinar, as well as relevant material, will be available in the BuildUp website. A Q&A session is foreseen towards the end of the event. Please send your questions via the chat function. They will be collected and tackled during the dedicated Q&A part. In case we don't have enough time during the Q&A session to address all the questions, please feel free to send your inquiry to our colleague Michelle. For administrative purposes, we would need to know the background of the audience of today's webinar. We kindly ask you to go to the Menti website as mentioned, insert the code that appears on the screen, and select the appropriate answer. Decided and the code will be available in the chat as well. It takes 30 seconds, it is completely anonymous and GDPR compliant. I will now give the floor to the first speaker and coordinator of the VEEP project, Dr. Anna Paraboski from RINA Consulting, an engineering consultancy company operative branch of the RINA Group. Anna, you can turn your camera on. Dr. Paraboski is product manager in RINA Consulting since more than 12 years. She holds a master's degree in civil engineering and PhD with meritum in hydraulic engineering. Her background is characterized by an extensive experience in academia as research assistant and co-supervisor for graduation thesis at the Politecnico di Milano University. Anna, the floor is yours. Unmute yourself.
Thank you very much, Alessio, for your introduction. Now I will go directly to the point, briefly introducing to all of you the project. Next, VEEP project is the acronym of a full title here reported, which relates to the development of energy efficient prefabricated concrete components, recycling, construction, and demolition waste, also called CDW. The project has been funded under the framework of the H2020 Research and Innovation Program by the European Commission, starting in October 2016, and it will be completed this month. It is a research and innovation action with a budget of about 5 million. We have 15 partners coming from 7 European countries. In particular, we have a collaboration of a relevant association as BIBM and the UNE, relevant research centers and universities as the University of Delft, the University of Leiden, Novatec, and Technalia. Industry is represented with the participation of precast manufacturers as a Nuovatesi company and Structon, construction companies as Siona, and engineering consultancy companies as RINA coordinating the project. We have also the participation of SMEs as STAM, Tionen, and Phoenix, and ADR and Key Aerogel. VEEP next. A VEEP project objective is to develop and demonstrate a series of technological solutions for the massive retrofitting of our built environment. In particular, we have designed and developed 2 multi-layer precast concrete elements, also called PCs, combining concrete and superstition material manufactured by using at least 75% in weight of CDW recycled materials. The 2 designed PCs solution have been conceived for both new building application and refurbishment application. A VEEP concept goes along the circular value chain for the construction, demolition, waste, recovery, and exploitation. In particular, at the beginning, we went through the development of novel technologies for treating the CDW. Then novel materials have been developed, in particular novel concrete formulation for both normal weight and lightweight concrete, and new aerogels formulation. With those materials, novel products, namely the 2 precast concrete elements, have been developed for new and refurbished buildings. The panels have been then used for building up 2 different types of mock-ups, which are being installed in 2 different climate areas in Spain and in the Netherlands to test the behavior of the panels under different climate conditions. A full LCA and LCC approach has been then adopted to assess the environmental impact of the different PCs. Panel dismantling enable at the end to assess the performances of the materials once the PCs would have been recycled again. Now I will go through the detail of the novel technologies developed. In particular, at the beginning of the project, we went through the design and development of 2 systems, the ADR and the HAS, which are capable to treat the coarse and fine fraction of the recycled concrete aggregate. Adopting these 2 technologies, we were able to achieve high quality coarse and fine aggregates. In terms of technologies, we have also developed a pilot plant with a capacity of 100 liters per day for producing a green aerogel. The green aerogel is characterized by a very low thermal conductivity and hydrophobic properties, but with a cost reduction of more than 40% in respect to the state-of-the-art aerogel. Novel materials have been also developed, in particular eco-cement and eco-concrete. The eco-cement were produced with 5% of ultra-fine recycled particles from the concrete waste, and new eco-concretes, normal weight and lightweight, were produced with more than 75% in weight of recycled material. The materials here mentioned were characterized by very good properties in terms of mechanical properties, thermal properties, and durability. The materials then have been used for producing the 2 types of PCs mentioned before, and have been used for the construction of the mock-ups, which are installed in Siona Demo Park in Spain and GBN facilities in the Netherlands, and which are under monitoring. It's worth underline that also novel lightweight plastic formworks have been designed and manufactured in the framework of the VEEP in order to reduce the time for casting the panels. Finally, we can conclude that even though there are technical barriers to incorporate the finest fraction of the recycled concrete in novel concrete, the development of the integrated ADR and HAS technologies movable system have demonstrated to improve the mechanical properties of the cement obtained, and this can help to overcome such barrier. Moreover, the positive results about the addition of the CDW aggregates in both coarse and fine aggregates can result in better concrete performance. And this suggested us to propose an adaptation of existing standards, as the one here mentioned, to allow higher percentages for the use of recycled concrete aggregates in the current building practice. Also, the eco-design of the PCEs can foster their commercialization in the future. Now, I thank you very much, all of you, for your attention. I invite you to visit our project website, watch the project videos, and follow us on the VEEP project and LinkedIn and Twitter account.
Thank you, Anna, for this interesting overview about the VEEP project. We will now explore the project step by step with the key specialists for each of the studied tasks. The first step of the project is the manufacturing of recycled aggregates with high quality that are suitable for use in precast manufacturing. But before inviting the first panelist, let's see together an introductory video produced by VEEP.
New concrete made of recycled aggregate must be suitable for a wide range of applications, and it has to be able to compete with primary materials in terms of workability, compressive strength, and durability. To satisfy all of these requirements, it is crucial to at least reduce the amount of fines and contaminants mixed with recycled aggregate. Here in this industrial site, the C2CA concrete recycling process is ongoing to create high-quality recycled aggregate out of high-volume end-of-life concrete stream.
So when a building has to be demolished, it is selectively dismantled first, which means that all materials which can be recycled, such as concrete, wood, metals, and gypsum, are separately collected. Then the concrete is crushed in small pieces, and it is then fed to the ADR. The ADR is a mechanical innovative separation technology which produces two streams, the coarse fraction and the fine fraction. The coarse fraction is already very clean and can be reused to make new concrete. The fine fraction goes to the HAS.
This is HAS, which stands for Heating Air Classification System. It is used to recycle the fine fraction of concrete wastes,
which produce two streams, the sands and the minerals. This way, we close the material loop and we effectively implement the circular economy in the construction sector.
ADR delivers three main products: coarse fraction 4 to 12 mm, air knife products 1 to 4 mm, which is mixed with floating and contaminants, and rotor products 0 to 1 mm with the highest amount of moisture content. After ADR processing, ADR coarse product 4 to 12 mm contain the contaminants and floating level less than 0.2 cubic centimeter per kilogram, and the amount of water absorption is between 4 to 5%. So this material is qualified enough to be sent to the concrete production next door.
I would like to invite now Professor Di Maio, Research Director of the Resources and Recycling Lab at Delft University of Technology. Please, Francesco, turn your camera on. Professor Di Maio is currently involved in projects aiming at developing effective and economically feasible technologies and methodologies that produce high-quality raw materials from end-of-life products. The goal is not to find ways to dump recycled materials into new or existing products, but to displace virgin raw materials. Francesco, please tell us, what are the main advantages of this combined ADR plus HAS system compared to the other recycling solution today present in the market?
Hi, Alessio. Thank you. And welcome to everybody. I see some strange noise here. Sorry. The main advantage of this technology is that it can sort materials, it can process materials when it is in the wet state. Sorry, Alessio, I have a very big noise. Do you have the same?
Yes, we have a big echo, like 2 micros on.
No, I don't have it on micros.
I'm sorry, these kind of things sometimes happen with these new technologies. Maybe while Francesco try and solve this issue, we can move to the next. We can. Francesco?
Does it work better now?
Yes. So we come back to you.
Yeah.
I repeat the question. What are the main advantages of the combined ADR and HAS system compared to the other recycling solutions today present in the market?
Yes, I was saying that before that the main advantage is that this technology can process materials in the wet state. You know, when demolished a building has been demolished, it is necessary to spray water to reduce dust. This means that you cannot use a sieve to separate sand or fines from the coarse materials, because of course with the wet materials you cannot do that. And then the advantage of this technology is that it can be done because of the principle, the working principle is quite innovative. Another advantage is that this technology, the C2C technology, which is IDR and the HAS combined, can also process all materials which can valorize all materials which are processed, not only one or two streams, but all the streams. And this means that from the economics of the process, it is very advantageous. And another advantage of this technology is the mobility. We can move the technology to the demolition site when this is needed. And this means that there is advantages in terms of the cost, environment, and so on.
Okay. And let's say from 1 ton of concrete and demolition waste, what are the outputs in terms of coarse, fines, and ultrafine particles?
Yes, in roughly speaking, if you have 1 ton feeding into the system, the IDR separate this in the feed in 60% of the coarse aggregates and in 40% of the fine. And the 60% is a very clean coarse aggregates, which can be used to make new concrete. And the 40% going to the heating air classification system is separated in about 30% of the clean sand and 10% of the fines. And both materials are very high quality, and they can be used also to make new concrete, or can be used to make filler, or even to be fed to kiln for cement production.
Yeah, interesting. And now let's also talk a little bit about money. What would be the price of such recycled aggregates, coarse and fine, for potential precast clients?
Yes, I mean, this is basically the quality of the aggregate is so good that if the feed materials is of a high quality, also the outcomes are of high quality. And the main feature, I think, is that we can definitely implement the circularity, because as you see in this table, we can recover 60% of the value which is fed into the system. This means that it is not just by only name that we can make circularity, but we can indeed make circularity in the construction sector. And I think this is one of the few ways in which the construction industry can turn into a more sustainable industry. We are very proud of the course of these results.
We are all of this in VEEP. Thank you, Francesco.
I'm sorry for the technical problem.
No problem. No problem. It was solved. That's the most important. And please stay with us. Please stay with us until the end of the webinar, because I'm sure that there will be questions on this revolutionary system for providing recycled aggregates that are suitable to make new concrete.
I'm glad to be here.
Yeah, to talk about the use of the ADR plus HAS system in concrete, we are with Mr. Jaime Moreno from Tecnalia. Mr. Moreno has a PhD in Material and Processes Engineering from École Centrale de Nantes. He has been working at Tecnalia since 2017 in the field of circular economy in the building sector. His current research interests include, amongst others, circular economy of construction materials, new technologies for the valorization of construction and demolition waste, industrial byproducts, and digital tools for improving the traceability and management of CDW. Jaime, let's start with the ultrafine particles from the HAS plus ADR system. VEEP demonstrated that it is possible to use them as partial replacement for ordinary cement. That looks fabulous, but how is it working?
Okay, thank you very much, Alexio, for the introduction. Well, answering to the question, Francesco has just presented the operation of the ADR and HAS technology that allows to obtain improved recycled aggregate and ultrafine particles, okay, with cementitious activity. Those ultrafine particles are improved in order to be used as filler, as Francesco said, or in the production of new cement. But the question is, do these particles have cementing properties? Can we employ them as supplementary cementitious material in new eco-cement? And what are the effects in new cement matrix? This is what we tried to demonstrate during the VEEP project. For that, we have performed different testing at laboratory scale, manufacturing different samples of standardized mortars, replacing part of a commercial cement. In this case, it was a cement 242.5 with 3, 5, and 10% of the recovered ultrafine particles. We employed the two types of ultrafine particle. The first one coming from recycled siliceous concrete waste, and the second one was limestone concrete, no, at the beginning. So you can see the result in this graph, and it was demonstrated that the optimal substitution was 5% of the commercial cement, and even we are ready to increase the compressive strength and the flexural strength by employing the ultrafine particles of coming from the HAS technology. But how does it work? What are the effects of the ultrafine particles in the cement matrix? We have detected that there are three main contributions of the ultrafine particles to the cement matrix. No? The first one is a filler effect. So due to the physical presence of the fine materials addition, the specific surface of the cement increase, and we have a better dispersion of the constituent. So we have further nucleation site for enhancing the hydration process. The second effect is a seed effect. So we are right to increase the hydration process by including new CHA nanoparticles that act as new hydration nuclei. And the third effect is as we have a right to regenerate the cementing activity of the ultrafine particle through the dehydration process applied by the heat treatment of the HAS technology. So the combination of the three effects induce an acceleration of the hydration process and a gain of the mechanical property both at early age and advanced age. Okay, so finally we have performed an LCA life cycle assessment of this new technology applied to the ultrafine particle applied to the new eco-cement, and we are able to demonstrate that more or less the substitution of the cement was equal to the reduction of the CO2 emitted. Okay, so we are able in this case to reduce more or less 40 kilograms of CO2 per ton of cement. It's important.
Yeah, sure, definitely. And now let's come back to the aggregate. The studied concrete contains 100% of recycled aggregates. And what is the impact actually on the performances of concrete?
Okay, so in a second stage, we try to demonstrate the effect of the recycled both fine and coarse recycled aggregate in new eco concrete in this case. So for the study, we have manufactured different combination of concrete, new concrete, with increasing the amount, the percentage of recycled aggregate, arriving up to 100% of recycled material, and also including the eco cement studied in the previous stage. So With that, we arrived to a total substitution of 75% by weight of natural material with recycled material. In this case, the result in new concrete, you can see the compressive strength at different stages of a reference concrete with the natural material, and the second one with 100% of replacement of coarse aggregate, and the third one with 100% of both coarse and fine recycled aggregate replaced by recycled aggregate. So here you can see that depending the age of the test, but more or less we are ready to maintain the compressive strength, the mechanical performance, and sometimes we even increase the mechanical performance compared to the reference one. So concerning the durability, we are ready to demonstrate that we have similar durability as the reference concrete. And about the workability, it's true that the workability decreased a little bit. The concrete has lower fluency, but we can solve this problem with other chemical addition. So this gives the opportunity of shifting the construction sector into a completely circular practice with guarantees, no? Both durability and mechanical guarantees.
Yeah. Yeah, I'm really impressed indeed. But imagine now that I'm a precast manufacturer and want to use these recycled aggregates for producing my next series of elements. What shall I take into account in practice?
Okay, so we all know that when using recycled material in new concrete, in new fresh concrete, the characteristic, the property are totally different. They are different from a normal traditional concrete. So we have to consider some recommendation during the 3 steps of the concrete manufacturing. The first one is during the dosage of the new concrete. We have to keep in mind that we have lower density of the new aggregate, we have higher humidity, and we have higher water absorption. So we have to think in having a strict control of the water dosage and the constituent dosage of the new concrete, recycled concrete. Okay. In the second stage, we have to consider some difference during the mixing of the fresh concrete. The mixing time to have to be implemented during the mixing of the fresh concrete is not the same as a natural one. Normally we have to mix more time, but we have to pay attention that if we mix more time, we can reduce the particle size distribution of the recycled aggregate because they are more friable than the natural one. So we have to have a strict control of the concrete evolution. And finally, we have to be careful during the pouring of the casting of the fresh concrete. Okay, we have slight losses in the workability and possible cracking during the curing of the concrete, not the fresh curing of the concrete. So we have to try to cast it immediately after mixing the concrete, and we have having a strict control of the curing process. This is the main recommendation that we can provide after the experience of the VEEP project.
Well, thank you, Jaime, for presenting us these encouraging results of the properties of concrete with recycled aggregates and cement paste replacement.
Thank you.
I remind all the participants to provide with questions in the chat. My colleague Michelle will collect them, and we will invite the panelists to give an answer during the Q&A session at the end. We have seen at the beginning that not only concrete can be made with recycled materials, but also insulation with astonishing properties, aerogel. Let's look first at the video. We now have with us Mr. Francisco Ruiz, responsible for aerogel in VEEP project. Mr. Ruiz is a chemical engineer from the University of Cadiz in Spain and later obtained a PhD in chemical engineering from the a PhD in the field of supercritical technologies applied to nanoporous material at the National Engineering School of Chemical Industries in Nancy, France. He has co-designed and commissioned more than 15 equipments of aerogel from lab to pilot scale. And in 2015, Mr. Ruiz co-founded Key Aerogel to commercialize affordable aerogels, mainly for construction market. Francisco, can you please tell us more about this silica aerogel? What differentiates it from other insulation materials?
Thank you, Alessio, for the introduction. So aerogel are an exceptional nanoporous solid composed by 98% of air and only a very little 2% of silica. And due to those properties, aerogel are the best insulator material known, with thermal conductivities below 50 milliwatt per meter per Kelvin. Today, compared with other insulation material, we only need a 15% of the thickness of the insulation for the same thermal performance.
Well, indeed, silica aerogel today is a material that exists and is mainly produced from natural raw material. What's different in the technology developed in the VEEP project?
In contrast to the standard raw material used for commercial aerogels today, where they are using the same product that is used for microelectronics, what is a very expensive raw material. What we have developed with our partner Technalia in the project is the use of construction and demolition waste, which has more than 50% of silica. We are extracting the silica and we are producing the aerogel directly with that. So we are obtaining an aerogel product, what we call a cycler, with a very low carbon footprint because we are using more than 75% on weight of construction and demolition waste. We are able to provide a very efficient, low cost production of the aerogel, and we are obtaining an aerogel with the same quality as any commercial aerogel with very good thermal properties and providing a very nice circular economy model. This system has been recognized by different international awards, where we should highlight the fact that this technology has been labeled like an efficient solution within the Solar Impulse Foundation.
Okay, and from the video, it appears that, however, cost and fragility are main obstacles in the use of silica aerogel on, I would say, commercial scale. How VEEP was able to overcome either or both of these issues?
Indeed, those are the global issues for aerogels today. And within the VEEP project, we work in both of them by optimizing a fiber reinforced composite, having the aerogel and being able to have and host the mechanical strength that the aerogel will be applied on while the application of the aerogel in the final panel from VEEP. But we also work in a continuous manufacturing line of the aerogel from raw material to final aerogel, and also on the optimization of the supply chain cost, where we will not have the long supply chain where the precursor is manufactured in a chemical plant far away, is transport we are using, and then we are selling the aerogel. We are hosting everything together in our production site, where we are getting localized and very close construction and demolition waste. We are treating them, we are making the precursor, and we are making continuously the aerogel that can be applied in a nearby construction.
Thanks, Francisco, for this very inspiring talk about aerogel. We see that you're really passionate about it. We are currently halfway through the presentation of VEEP. I hope that you still enjoy and are getting useful information out of it. Combining concrete and aerogel insulation, partners of VEEP project designed and produced 2 precast concrete panels that will be introduced in the following video. We now have with us Ms. Giorgia Ragno from STAM. Please, Giorgia, turn your camera on. Ms. Ragno holds a master's degree in civil engineering at the University of Genoa. Her technical background is mainly focused on energy efficiency, environmental sustainability, circular economy, and innovation projects, integrating natural resource management and planning, design of alternative bio-based technologies, biomass recovery, and creation of bioproducts value chain. She has pluriannual experience in the development, collaborative research, and technology transfer project. Giorgia, first, please tell me, why did VEEP develop 2 types of panels? What are the differences between them?
Good morning. Thank you for giving me the floor. The 2 panels developed in VEEP project are 2 different panels. One is the PC1, that is a load-bearing panel designed for new buildings, and the second one is the PC2, designed for non-load-bearing purposes, and in particular for refurbishment of buildings. PC1 has a higher thickness. It is made up of 3 layers, 2 concrete layers. The external one is 6 centimeters. The internal is 13 centimeters, and in between we have 7 centimeters of aerogel. This construction element, as I said, is commonly used for industrial buildings. The PC1 concrete mix includes normal weight recycled concrete and aggregates, up to 75% of weight of replacement. The compressive strength is higher than 40 MPa, and it has 240 minutes of fire resistance. It has a lower weight per square meter and a higher U value compared to a standard construction element similar to this one. While the PC2 is, it has like a lower thickness. It is in fact 13 centimeters. It still has 7 centimeters of aerogel and just 6 centimeters of concrete. This specific type of construction element has, again, a higher quantity of aggregates, recycled aggregates, and low weight concrete, recycled concrete. And it has a fire resistance of 90 minutes. The innovative panels were cast using innovative plastic formworks aimed at optimizing the casting process. And not always that, but also the molding and the panel finishing was enhanced thanks to this specific production with plastic formworks.
Okay, yeah, indeed. Let me tell you a little bit more about this, because beside the panels themselves, these plastic formworks and 3D printed connectors have been developed for VEEP. Do you think that they can be used on a daily basis by precast manufacturers?
We know because we have tested it during the process. The formwork preparation and the molding are high time-consuming phases in the overall panel production workflow. And VEEP targeted these phases in an innovative way, as I said. So we rethink the way of the preparation of formwork using the specific design, flexible and modular innovative plastic formwork with, let us say, smart engagement and disengagement system through magnets. So the formwork are easily placed, and and the different type of shapes are composed on the casting table, and decrease the assembly time to 4 minutes, and that is at least 1/4 of the normal time using for casting, let us say, 1 square meter of panel, of precast panel. Then the other innovation that we adopted during the casting phase of panels are the adoption of these connectors that are actually just prototyped for now. So what we did, we designed and we modeled the behavior of these innovative connectors. And we also used the recycled plastic filaments that was obtained during other processes carried out in VEEP. So we obtain a brand new design of a connector using VEEP material. This is quite an achievement. The connector allows an easy disassembly. It means we are not going to destroy the different layers, while we'll manage to reuse the insulation that we know is extremely valuable, because as we said before, it is the aerogel, the innovative aerogel. So this is quite an improvement.
Yeah, definitely. And well, coming back to the panels, do you think that they would already be competitive on the market today, or what is needed to make them even more competitive?
As I said before, with adopting our technology, the panel production is faster, and fewer operations are performed to produce one panel compared to the say, standard or traditional manufacturing process. And furthermore, the footprint required by the production is highly reduced, as I said before. And also, this is due to the reduced panel weight and to the, adoption of recycled material. Furthermore, the thermal efficiency is improved, and this is, this is due to the aerogel. So all these elements, concur to the, let us say, increase of competitiveness of these innovative products. Last but not least, thanks to the innovative formworks, we are able to avoid the effect that you see in the left picture, where there is the effect that is called the seepage of concrete. Through the side of the traditional formwork. Why? As you see in the right picture, using our formworks, this effect is abolished. You cannot see anymore any seepage, and this is I mean, this gives this effect of perfect finish to the edges of the panel. I mean, all these elements, I mean, increase the competitiveness, and for sure, is if properly communicated, will spread. I mean, the awareness of the, I mean, the benefits of adopting new materials and new techniques.
Thank you, Georgia, for presenting us the VEEP panels in such a clear manner and short time. Well, as Anna told at the beginning, more information on the project results is available on the VEEP website, www.veep-project.eu. Once manufactured, these panels have gone through thorough on-field testing. The mock-up is presented in the following video. Not only real tests have been performed on the panels, but calculation of life cycle assessment has been performed as well. To talk about it, we have with us Dr. Mingming Hu and Mr. Chumbo Chen from Leiden University. Dr. Hu is assistant professor in the Industrial Ecology Department of the Institute of Environmental Sciences. Her research focuses on sustainability of the built environment and has been involved in several EU and Dutch projects in the field. Mr. Chen is PhD candidate in the same department. Additionally, he holds a master's degree in management and a bachelor's degree in engineering. His work focuses on the environmental impact and resource consumption of the built environment. Mingming, Chumbo, from a life cycle assessment perspective, what are the benefits of using recycled aggregates and ultrafine particles?
Thank you, Alisa, for the introduction and for the interesting question. The benefits of using the recycled aggregates and the ultrafines are mainly nine on the saved transportation for the end-of-life concrete, which are really big volume in our construction and built systems. And the second large is from the potential saved use of cement. So we have already carried out the environmental life cycle assessment and the cost and land analysis for the VEEP innovations, which is the combined use of the ADR and the HARS system for the processing of the end-of-life concrete to produce the useful coarse material, fine material, and the ultrafines with the cementitious property as introduced before of our project partners. We compared it with another three alternatives, which is the traditional one in the market, the wet processing of the washing, the coarse aggregates, and the stationary and the mobile ADR system. The results show on the right hand of your screen, the main saving we can expect are from the saved transportation, which is shown in the blue. Once the mobility is secured, then this part of the emission and the cost can be saved. The second comes from the saving of the primary production, which are shown in the green. For more details, we invite you to read our current publication, which is listed on the below of the screen. Thank you for the question.
Thank you. And now let's go to the panel also from life cycle assessment perspective. Are VEEP panel better than the ordinary ones?
Generally, we say yes, but it largely depends on how much we can really reduce the emission, the production emission, and the cost of aerogel part. My colleague Chunbo will give you more details.
Yes, according to our LC and LCC studies, for manufacturing of PCE 1 and 2, aerogel accounts for more than half of the costs and emissions. For PCE 1, you can see from the bar chart at the top. If we apply it for a new building with a lifespan of 120 years, the life cycle cost and emissions will be just slightly better than the business as usual reference. So further improvement should focus on reducing the production cost and the emissions of the aerogel. And for the PC2, you can see from the figure below, if we apply it for energy retrofitting, especially for old buildings, clear advantages on emission mitigation and cost savings can be expected. However, the economic viability of the PC2 is highly dependent on its reusability. And if we implemented the PC system to the Dutch building stock, you can see the figures at the right side. It is an environmental and financial win-win solutions. So more than 90% of the savings will be from the PC2.
Yeah, and from for further development, what would be your suggestion for an improvement of the sustainability of precast concrete panels?
Yeah, just as we said, we found the key is really to improve the reusability of our PCE panel, because that is the majority, PCE2, the majority application. Also, we use the case study in the Netherlands to see there's a huge potential out there. And the second is still to reduce the production cost of the aerogel if possible. If not, then try to optimize and reduce the use in the panel as much as possible, the aerogel part. Chunbo can give you more explanation on this.
Yes. So first, for PC2, we need to enhance the reusability of it. And the realization of the reusability can further reduce the cost and emissions for production of a new PC2. According to our estimation, successful reuse can reduce, let's say, 23% of lifecycle cost and 11% of lifecycle emissions. And second, for the PC1, if we further optimize the cost effectiveness of the aerogel layer, there will be a big economic advantages. The EU regulates the building constructed after 2020 should meet the standards of nearly zero energy buildings requirement. So one possibility could be based on the requirement of the zero nearly energy building of each member states to adjust the thickness of the aerogel layer for different climate zone. That's it.
Yeah.
Thank you, Mimin. Thank you, Chumbo, for this analysis. We know the importance of a sustainability assessment for new products to be successful in a competitive market like the construction one. So we are now come to the end of the VEEP presentation. I would like to thank again all the panelists of this session, because they were able to summarize in less than 1 hour a project that has been running for more than 4 years. And I also take the occasion to thank all VEEP partners that have contributed to the achievements of such successful project and cannot be with us today. But please stay with us with the upcoming clustering and Q&A sessions before the final wrap up by the VEEP project coordinator. The first clustering project is ICEBERG and will be presented by Mr. David Garcia Esteves from Tecnalia. Mr. Garcia is a senior researcher with a PhD in materials engineering. He has been working at Tecnalia, the largest private research center in Spain, since 2006. His current research interest is in the field of eco-innovative materials and services in building and civil applications. as previously coordinated projects like IRCOW under the 7th Framework Program and HISER under Horizon 2020. And nowadays, he's project manager of ICEBERG. David, the floor is yours.
Thank you very much, Mr. Rimoldi. And thank you to the audience and to the VEEP project for inviting ICEBERG to be part of this wonderful event. Well, ICEBERG is one of the last Horizon 2020 projects on circular economy in construction. The project, as you can see in the first slide, well, has an attractive title and has started 10 months ago. So we are still at the beginning of this project. So in my presentation today, I would like to show you the main objective and the main activities that will be developed during the next 4 years. Yes, the main objective of the project is well, to continue developing and demonstrating technological and also non-technological solutions to achieve greater recovery of raw materials containing construction and demolition waste, and also use those materials in new building products, incorporating them into the circular economy value chain. So this project, well, takes into account the results of previous European and national projects, and the idea is to upscale and integrate some of the existing developments and technologies, taking into account the different stages in the life of the buildings. This is the concept of the ICEBERG project. As you can see, we decided to start it at the pre-demolition stage. Doesn't matter at what point we start, because at the end we consider the buildings as a circular process, but just by methodology we decided to start at the pre-demolition. So in all those different stages we want to make additional contributions. For example, in the first one we want to develop new digital solutions for the quantification and planification of the demolition activities. Later, we will develop some technologies for the automatic identification, sorting, and recycling and purification of the different materials. In this project, we are dealing with the main materials included in buildings. So in the project, concrete, ceramics, gypsum, wood, and also insulating foams will be considered. Once the materials are recovered, we will use them for manufacturing new building elements. Through all the process, we will follow a traceability system using a new platform for that. And with all those solutions, we will demonstrate them in several case studies. So if we move to the next slide. Here, well, you can see that the innovations of the project can be clustered in 3 groups. The first one are the smart services and software related with the pre-demolition activities and traceability issues. So part of these innovations will be a new software to support the demolition activity, demolition process, and also the decision making. And also a traceability platform in which we will include the information related to the waste identification, the quality control, the different actors involved in the collection and in the purification of that waste streams. In the second group, there will be room for new and upscaled advanced sorting and recycling technologies. For example, we are planning to develop a mobile automatic sorting line with hyperspectral imaging sensor. So with this equipment, we plan to automatically separate ceramics from concrete, or also removing gypsum from the ceramics and concrete, and also trying to purify the different materials before the later recycling stages. And also regarding recycling technologies, well, we will consider some of the solutions already developed at low TRL in previous projects, but we will upscale them and we will integrate them in more close to the industry solutions for the different materials that I mentioned at the beginning of the presentation. Finally, once we have recovered the different materials, there will be an eco-design process for new circular building products. That means that we will not only include high amounts of recovered materials in new building elements, but we will also take into account the eco-design rules for designing those elements. So planning that in the future, those elements will be easily removable from the buildings. They will be more easy to recycle, etc. In the next slide, you can see that the activity will not stop at lab or at our facilities scale, but all the activities will be later on, after in the third year of the project, will be demonstrated at a very high TRL in 6 case studies in 6 different locations in Europe. In each of those case studies, there will be different materials, different solutions considered, but they will follow the same. They will contain the same activities. So in all of them, there will be some activities relating with the pre-demolition audit, the preliminary study of the expected wastage in the building. There will be a plan and a demolition project using selective demolition techniques. There will be the waste processing and the use of that waste for recycling and for obtaining new materials. With all those recovered materials, we plan to manufacture new elements that will be again installed in representative building spaces. And in all that steps, we will use the new digital traceability service to include information about the different options during the demolition, the material recycling, etc. To use that information to quantify the environmental impacts, the cost, the source of the different materials, in order to increase the confidence of the final users on those recovery solutions. Finally, after several months, we will also simulate the disassembly of some of those materials to be sure that they can be easily disassembled. And in all the process, we will perform a parallel analysis of the environmental and economical aspects of the new technologies. Well, this must be a very short presentation. Of course, there are other activities, other transversal activities, like those related with the analysis of standards, policies, and social awareness. Also, communication activities. And regarding this, I would like to invite you to follow our activity in this project, joining the list of the interest groups in our website and the e-newsletters that are released every 4 months. Also in the social networks, in which we try to be quite active. And in these sites, you will be informed about the next events of the project, in which I hope that we will present the first results. Next slide. Well, I didn't mention at the beginning, but this project is a very large one. The consortium is composed by a total of 35 partners with additional linked third parties. The total budget is over 15 million euros. So there are much more activities that the ones that have been presented here today. I invite you to contact us as coordinators or any of the participants in the project and follow us in the website and the social networks. Thank you very much once again for your attention and for the invitation from VEEP.
Thank you, David, for the introduction on this ICEBERG project, and all the best for successful achievement of its objective. I will now move to the second project, which is Ceramco, in which BIBM was also associate partner. I say was because the project is concluded and its results are today presented by the coordinator just after the Ceramco video.
Finn, wo kommen denn die ganzen Steine her?
Wir haben gerade unsere alten Häuser abgerissen, die wir nicht mehr brauchten.
Aha. Und jetzt, Nils?
Jetzt müssen wir erst einmal alle Steine sortieren. Cool, was wir alles aus den alten Steinen bauen konnten. Es wäre mega cool, wenn wir hier ganz oben wohnen würden. Hey du, kann man auch aus alten Häusern neue bauen?
Ja, daran arbeiten wir.
Hey, cool!
Ceramco provides solutions to recycle and reuse construction and demolition materials in new building structures. Ceramco contributes to reduce the ecological footprint of the construction industry.
Yes, dear Alessio, dear all, and dear Alessio, thanks for the kind introduction. Dear all, I'm happy to be with you. Alessio, you want? I can start on because.
Yeah. I mean, you just wanted to briefly introduce you. So you are the coordinator of the project, Professor Christian Glock. You took over professorship in the Department of Civil Engineering at the University of Technology in Kaiserslautern in October 2017. After studying construction engineering at the University of Darmstadt and Oulu, Finland, you joined the company Bilfinger in 1999, where you had a wide range experience in construction and real estate business. You have been member from 2013 to 2017 of the executive board of Bilfinger Hochbau GmbH, and amongst other, you are active in various European and German committees and board. Christian, the floor is yours.
Yeah, so thanks, Alessio. I was too fast. Thanks for this. Yeah, dear all, I'm happy to be with you and to give you some results to our Ceramco project. First of all, the cryptic acronym Ceramco means secondary raw materials for concrete precast products. And yeah, I'm lead partner of the project, and I hope the video gave you a first impression about what we want to do in the project. Due to the short time, here in short our project goals. Yeah, we want to increase the reuse of construction waste as secondary raw materials for the production of concrete and as well cement for both parts. So for that, we first develop new processes for high quality recycling, and then we improve mixtures for cement and concrete. And again, here cement as well as concrete. We do this in order to produce innovative concrete precast products from these recycled materials. Of course, due to market reasons, we want to inform stakeholders, probably also as doing right now, and showcase this with 3 pilot projects at the end of the project. The next slide, this slide shows you the overall project. The blue box shows what happens today. The most construction demolition waste ends up under road construction. We are thinking about the green tomorrow. So we want to deconstruct buildings, have the sorting process as high quality, and use the fine grades for the cement production and the coarse grades for the concrete production as aggregate to rebuild buildings. At the right side, you see the project members sorted to countries. And how do we do that? Next slide, please. Due to the short time, I just focus at the end products. As you know, the project is now finished. Of course, it was a long way running, and I promise to show you links to find all the information of the project. How did we do this with the precast products? We used the geniusity of young students. Here, a picture of TU Delft. The students made over 100 ideas. Next slide, please. Over 100 ideas of possible products using recycled materials. We focused these to 24 ideas which were worked out properly. Next slide, please. You see here, and then voted in between with the project team of Ceramco 10 products to be produced within Ceramco project. The next slide shows you some examples of the products. Of course, we also always thought about mass production and on the other hand of fancy products to turn image of recycled products. The left one is a precast wall. You can use it with, sorry, back again. The left one was the precast wall. As you see, you can use the insulation inside, or you can also pour in concrete as massive construction. In the middle, you see a gabion wall, where we measured at the lower picture at Tradicoval, one of our project partners, how we could cool down the air due to vaporization. On the right side, you see pavement, which is also possible with recycled products. The next picture slide shows you an energy bench. Next slide, and this energy bench. This is one of the products to turn out image of recycled aggregates. You see here the bench in our lab in Kaiserslautern. It's made of recycled concrete and furthermore uses the mass and temperature difference by a Pelletier element to have a lightning, as you see in the visualization down picture, or you can charge your cell phone. Furthermore, we also have pilot projects. The pilot projects you can see in the overview are 3 projects. At the top, you see Serang in Belgium. Then we see Thionville in France and Pirmasens in Germany. I just focus on 2 of them. The next slide shows you the pilot project Thionville Porte de France in France, of course. Here we have showcased the L wall, as you see, with the letters inside of it, made out of 100% recycled aggregates from our precast partners, which shows a real great quality. So L walls is really no problem doing it with recycled materials. And the next pilot I want to show is just this picture is just 2 weeks ago. We finished the pilot pavilion in Pirmasens in Germany. It's about 40 square meter, made out of various products from Ceramco. So of course you see the walls as prefab elements, filled in by recycled concrete in situ furthermore, and you see the roof construction, which is also from design purpose. Both made out of recycled, all made out of recycled materials, and we hope that it will give benefit to the city of Pirmasens. Let me come to the conclusion. Yeah, what are our conclusion after 3.5 years? So I'm very sure treatment processes for secondary raw materials are already on a high level. The use of secondary raw materials for production of cement and concrete is very well feasible. And even more, they are feasible for precast products. But now downside, the barriers for wide market penetration are low-priced raw materials and legislative framework of public sector. This has to change to improve usage. At the next slide, you'll find all of the information of the project. We have made 7 videos as the one you've seen. This one was done for Registrars Award, where we were happy to be voted as a finalist. You have all the presentations from our final conference, also have been done in January as a web meeting, and the conference paper of this conference. Furthermore, you see the overall project partners on the right side of the slide and my contact data. Thanks a lot for your interest to my project, and I'm happy if you contact me for information. Thank you.
Well, thank you, Christian. Well, to the audience, you don't have to write down all the web addresses that were in the previous slide, because this will be available in the Learn section of BuildUp after the webinar. And Christian, please let us know if you are planning to do a follow-up, because that would be very, very interesting indeed. And I will not...
Indeed.
Yeah. Yes, please.
I thought it was a question. Yeah, we're doing a follow-up project called CMAP 3D printing with the fine grades. So we're happy to use this for further research.
Oh, great. It is now indeed time for a long-awaited question and answer session. We still have 10-15 minutes for this. But before that, I think it is useful to have a view of the audience of today's webinar as a result of the Menti questionnaire that we had at the beginning. Thank you very much, Michelle. We see that it's mainly coming from the research community. Second part from the industry. Thank you. I will now invite all the panelists to turn on cameras and microphone. During the whole seminar, my colleague Michelle, that you haven't seen, and with the support of BuildUp, have collected all the questions, and I tried during this last two presentations, I tried to aggregate them in order to have them covered as well as possible. Well, the first one is quite an easy one. Basically, can the VEEP panels be fully circular themselves? That is to say, can they be recycled with the ADR technologies without leaving too much contaminants in the recycled aggregate at the end? I don't know if this is for Georgia or somebody else want to answer this.
I can start, yes, just to launch the discussion, Alessio. Because in the framework of the project, we had in fact a task which is going to be completed this month. That was foresaw the assessment of the recyclability of the materials of the panels once the panels have been dismantled. In order to take the time for monitoring longer, we choose to produce an extra panels to do this activity and to destroy them and assess the properties of those materials. Maybe Professor Di Maio, Francesco, if you want to add any comment, it's more than welcome, because it was also foresaw the participation of you that this.
Yeah, I mean, for sure, it is if the panel can be dismantled and separate, and we can separate the aerogels. For sure, we can totally recycle through the C2CA technology to the IDR and HAS, because the cleaner the materials is fed into the system, the cleaner it gets out. It's clear. And as I mentioned in my short presentation, we can already recover most of the value in terms, really indeed, of a monetary value from any end-of-life concrete. Then if this applies to any concrete, it applies even more for panels, which are by definition more cleaner.
Thank you. Anybody else want to intervene on this?
I would like also to add that the aerogel is also fully recyclable with our process. The same, we can treat the silica coming from the construction and demolition waste. We can treat the aerogel because it's composed by silica.
Thank you. And well, as you are we are the last to speak, there is also one question to you. What does the aerogel cost?
Well, the cost of the aerogel, it will depend on the kind of shape. What we were using for the project, it was panels of 1 centimeter thickness, and we were keeping the production cost of those panels close to 10 euro per square meter and 1 centimeter.
Okay. Yeah, because indeed I see also other questions that, as I say, try to aggregate, which are indeed more linked to the putting on the market of this project. Sorry, of this product. So the first one of the question is there already some real buildings that are planned to be built with such panels? Do you know, Anna? Maybe.
Anna,
yeah, we lost.
Yes, because I was still muted. The project was a research innovation action. So in the framework of it, we aimed to evaluate the possibility to enlarge the amount of the use of the construction and demolition waste percentage in effective concrete formulation. And we also provided the feasibility of having novel sandwich panel design, enabling the exploitation of these novel materials and the aerogel as well. So yes, it's more, it's our, let's say, expectation afterwards to make this project real, but there's not at the moment the plan for building, you know, we have not a project aiming to have a VEEP panel buildings. But what we did is to start the assessment of the performances of the panels via monitoring of our mockups, because as it's the inner nature of a research innovation action, we aim to propose novel methods and technologies in the framework of the project. Then the steps are to move afterwards with further innovation action and other kind of projects in order to take the results to the market. Yes.
Anna, Alessio, may I add a small comment? I want to mention that according to the business plan prepared also by RINA, this business plan showed that there is quite some possibility to exploit the recycling technology in Europe.
Yes. Yes, in fact, from a feasibility point of view, the project concept is fully consistent. Also from the business perspective, we assess that.
And we are getting quite some interest from company worldwide. I want to mention worldwide companies are contacting us because they are interested in making construction sector more circular.
Yeah, well, because I have here, that's good because that makes the link with the next question, which is if indeed the ADR HIS technologies on one side and the Silica Aerogel on the other, if they are mature enough to be applied in an industrial scale.
Yeah, I mean, from the ADR and HIS, they are, as I mentioned before, we have been contacted by several companies. They are really interested in making the construction sector more circular, and then they have to find a way to do it, and not only just mention we are more circular, we are more sustainable. They have to do something, and yeah, there are not so many routes to go. And one route is definitely to reuse the materials from end-of-life structures. If you wanted to really use the materials from end-of-life structure, you have to have effective and cheap technology to reuse these materials. And we have proven that the materials we produce are definitely good to make high quality concrete, and they can even be used to for other purposes, like the fines can be used as a filler or for as a feed for cement production.
Francisco?
That's interesting.
Yeah, in the part of the aerogel, we are also getting to the industrialization due to the interest of this material for construction, and we are commissioning our manufacturing plant, who would be running in the coming month. So yeah, we also see a huge interest for increased efficiency of our buildings through high performance material like aerogels.
Actually, Alessio, I didn't mention before, but the system can process 80 tons per hour of materials. Then we are not talking about a small machine. We are talking of a system processing 80 ton per hour of end-of-life concrete.
Yeah. Yeah, and indeed, next question is it takes a little bit also on what Christian said, and that's about the legislative barriers. Which kind of barriers did we find during the project, and how have we planned to overcome them? For example, with contacts with national or local authorities. So that's a question maybe both for Anne and for Christian.
The ladies first.
Gentlemen.
Go on, Christian. We are on a gender parity.
Then I start. Sorry for being unpolite. Yes, indeed, it's a real problem, Alessio, but we solved it for the pavilion you saw, because it was in the public area and of course had to meet all criteria to not harm someone in terms of safetiness. So we did a lot of research work and pre-testing and proofs, which is possible within a research project. So we got all approvals for that, but seeing it on a commercial way, it will be very difficult to have this competitive. So I'm very sure we need to overcome the problems of standardization, because standardization always is not friendly to innovations. It cannot be, because you can only standard knowledge you've already have for many years, and it meets all small parts and connectors. Everything in Germany at least has permissions for only determined circumstances, so we can overcome them. We can overcome them by research and by approvals from experts, but we have to, and we talked in Germany and other countries, we have to put it in standards, otherwise it will be always a hurdle.
Yeah, I agree with Christian. If I may add a short comment also here, I think we should also get rid of the analysis done in the lab. We have to have a fast system to process and to check the quality of the materials we are producing, and it cannot take days to get the results of such analysis. That's why we are working also within the ICEBERG project, the one presented by David, to make a system, to produce a system which can definitely check the quality of the materials produced by the recycling systems in only in few seconds, and then we know we can apply the knowledge collected by this system to decide whether that material can be used to make concrete of a high quality, or if not, what type of a concrete can be produced by that materials, and or to do some lower quality product which do not require high quality material. But then we can definitely know what product can be done based on the analysis of this advanced innovative quality system.
Thank you, Francesca. Just get the information that we can get 10 additional minutes. So if I kindly invite the audience to stay with us, if possible, for these 10 minutes, because this gives us the possibility to go also through another couple of questions. That one is for ICEBERG and the pre-demolition tool. If the question is if it is able to predict the amounts of the different types of material which will be produced in a demolition or construction project.
That tool is composed by different modules. In fact, in a previous project in ICEBERG, we already developed a tool that is able to quantify the different waste streams, combining the information gathered for the BIM model of the building and some databases. In this project in ICEBERG, we want to include also some additional functionalities. So the tool will be able to recognize certain elements, for example, a door or a window or an element. And also there will be additional plugins for the faster identification of elements. So with all that information, the tool will be able to inventory the elements in the building using the description of the materials according with the list, with the European list of waste. And depending on the demolition process decided by the user, it will be able also to forecast the total amount of waste after the demolition. With all that analysis, the tool will also estimate the related environmental impacts. And that information, we think that will be very useful for the decision making before starting the demolition process.
Okay, and this tool is you can integrate it with BIM as well.
Yes, we follow BIM methodology, but one of the main drawbacks identified in the previous projects was the necessity of having a preliminary BIM model of the building. In this new project in ICEBERG, we are developing a modulus for the drawing of the building. Sorry for my English. So the user can very quickly draw the walls, the doors, all the vertical elements of the building. So it will generate a 2D drawing, and the drawing will also collect the semantic information of the different elements. So we will follow the BIM methodology, the BIM terms, but it will be not necessary to have a full detailed BIM file of the building.
Okay. Well, next question, I think it's going to be for Jaime and concern the methods, which methods have been used to determine the durability of elements made with recycled concrete. Because I think you mentioned that these elements has similar durability as elements with normal aggregate. So how have you assessed this?
Yes, the best way to assess the durability of the concrete is to place the concrete in a real scenario and to take some sample after some years. But in a laboratory scale, we don't have time for that, so we apply accelerated test for measure the durability of the concrete. So I don't know the number of the standards now, but we have different tests as the water penetration under pressure, the accelerated carbonation. We apply also freeze-thaw cycle for test the durability under change of temperature and humidity. And I think there is another one that is a chemical attack of the concrete. Okay, so with that, we arrive to simulate or to estimate the durability of the concrete, and we compare the recycled concrete with standard one, with normal one, and we evaluate the possible durability of those concrete. But now I don't know I don't remember now the number of those tests, but yeah, they are standardized test at European level that we can apply to those materials.
Okay. Well, another short question, I guess, for Francisco. Is there a technical approval for the usage of aerogel or any other guidelines?
Yeah, it's depend. To my knowledge, I think some countries in Europe, they have already technical approval, but there is also an ICO going for the fiber reinforced aerogels. that will be applied soon, but there are some certifications that are already available for the application of aerogels on construction. When we go to granules, it's not as advanced as fiber reinforced aerogels, but it's also ongoing for some standardization or certifications.
Okay. Another question for Francesco. The cost estimation from the ADR plus HAS technology at 80 tons per hour capacity. I guess that's yeah, cost estimation.
Yes, it's a cost estimation of only that the two systems you mentioned is about 800,000 euro, something in this order of magnitude. But if you wanted to make the full system, then you need also crushers, you need sieves, you need other conveyor belts, other equipment needed to be combined. Then the price, the cost goes higher, but it is still economically feasible.
Okay, thank you. Well, I have one last question, but I will, as the answer to the question will be, I guess, in the conclusion from Anna, I will ask it just later on. So I would like to now close this this Q&A session, and thanks again all the panelists for being instrumental to the success of the event, and also to Michelle that I invite to join us. That was the key enabler for this, I hope, successful event, working behind the scenes during the full day. And thanks also to all the participants for your time and attention. We hope that we have been able in such short time to give you a flavor of some research that is being carried out in the field of circular economy for the built environment, where precast concrete solutions play a major role. So I now give the floor to Anna with the final question, which is, what are basically the next steps and how can we implement this technology better in the market? So Anna, the floor is yours, and to all the others, stay healthy and see you again on another occasion.
Yes, in this sense, we are working already in order to improve our achievement that we reach within VEEP, in particular in order to scale up the technologies. Because, as mentioned, the technologies for treating the CDW have been here developed in order to be movable, but the capacity of the ADR and the HAS are still different. We have 50 ton per hour the movable system ADR and 3 ton per hour of the HAS system. So what we are working on, and this activity will be further developed in the framework of the ICEBERG project, is to scale up the technologies in order to have the combination in series of ADR and HES to have a similar capacity in order to close the gap, which is still quite high at the moment within VEEP for the treatment of these technologies. This will open the door for novel methods for having the production of the concrete exploiting the CDW, because we can have a movable system which could be put on site and have the production of the concrete in the future in line with the demolition, of course. This is clearly a vision, but I think that the positive results that we have already achieved in the framework of VEEP suggest that we have to commit to continue in working on this topic in order to make the sustainable development and the circular economy in the building sector be real. So I take also now the chance to thank all of you, also the partners that have contributed to achieve the VEEP results that have been, it's been a real an honor and a pleasure for me to work with all of you. to the partners today contributed in organizing this event. So thank you very much, Alessio, Michelle, Georgia, Francisco, Francesco, Ming Ming, and Chumbo, and Jaime. That really, it's been a pleasure to work with you and all the VEEP partners. And I thank Professor Glock and Dr. Garcia that shared with us the vision of their project. And okay, so what else? Build up for having supported us in organizing this very nice event. Last but not least, I take the chance to thank also our partners and the attendees that today registered and attended the event. Maybe if you, Michelle, can we show the last slide?
It is already shown. Yes.
Good. Very, very good. So I take the opportunity also to invite all of you to visit our website and watch our videos and publication, and to register to the replicability workshop that will be held tomorrow. That's the agenda. I'd like to comment a little bit. Michelle, the previous slide, okay. So tomorrow there will be this event organized between 1 p.m. and 2:30 p.m. It's about the replicability of the VEEP solution. We will go through the CDW scenario in Europe, Latin America, and also Asia. There will be the speech from Alessio Rimoldi from IBM, Jaime Moreno and Carlos Roda, respectively from Tecnalia and the Studio Pitamiglio, and also from Dr. Zhang and Professor Wu from the Leiden University. So I invite you to register to this event. Michelle will share with you the link to register to the event in the chat. And I invite you, if you wish, to share with us your contacts. You please do not hesitate to send both to me and Michelle your email, in order that we can keep you informed once we upload the novel contents on the web site of the project, so you can keep let's say updated on the project.
Thank you, Anna. Thank you, Alessio. Thank you again, Build Up team. I will now going to close the event. So thank you to all our attendees for following us today. You will find event registration and all material on Build Up. So just visit Build Up website and you will find all the content there. Thank you very much, and I'm closing the meeting now. Bye-bye.
Thank you. Bye.
Thank you. Bye.